Monte Carlo simulations provide powerful estimates, but they can be inefficient if variance is too high. Variance reduction techniques help improve accuracy without requiring an excessive number of samples. Let's explore some key methods. 1. Antithetic variance. This technique reduces variance by generating pairs of negatively correlated samples. How it works. Instead of using completely independent random numbers, we generate one normal sample and then create a mirrored version of it. By averaging both values, we get a more stable estimate. Example: if one sample overestimates the result, its antithetic counterpart is likely to underestimate it, leading to a balanced estimate. 2. Control variance. This method uses a related variable with a known expected value to adjust the Monte Carlo estimate. How it works. Identify a variable that is correlated with the quantity we want to estimate. Since we already know this variable's expected value, we use it to adjust the Monte Carlo estimate, reducing variance. Example: in finance, estimating the price of a complex option can be improved by using a simpler option with a known price as a control variant. 3. Importance sampling. Some parts of a distribution contribute more to the final estimate than others. Importance. Sampling helps focus more samples where they matter most. How it works. Instead of sampling uniformly, we bias the sampling towards more important regions of the distribution. We then adjust the weights to correct for this bias. Example: in rare event simulations, we don't want to waste samples on common outcomes. We focus on the important rare cases. 4. Stratified sampling. Dividing the sample space into strata, subgroups, and sampling from each separately ensures better coverage. How it works. The total range of possible values is split into smaller sections. Instead of random sampling, we ensure that each section is sampled proportionally. Example: when estimating the average income in a city, stratified sampling ensures that each neighborhood is represented correctly. Why are variance reduction techniques important? Faster convergence. Achieve accurate estimates with fewer samples. Lower computational cost. Reduce the need for excessive simulations. Better reliability. More precise results with the same number of samples. Conclusion: variance reduction techniques improve the efficiency and accuracy of Monte Carlo simulations. By using methods like antithetic variance, control variance, importance sampling, and stratified sampling, we can obtain better results with fewer resources.